Hello everyone, welcome back to my channel. In this video we will discuss rule of thumb for evaluating soft toric contact lens rotation. We know that in toric lenses cylindrical prescription is present. So if the contact lens rotates on the eye, then the axis of the cylindrical lens also changes. So it is important to know how to assess lens rotation and how to manage it. So in toric soft contact lenses, there is a lens mark. If this is a toric lens, there is a lens mark. Usually, it is placed at 6 o'clock position. Now, this lens mark does not indicate the axis of cylinder. This just indicates that if it is present at 6 o'clock position, then the fitting of soft toric contact lens is good. Okay. So when we fit soft toric lenses, then we examine contact lens with the help of a slit lamp and we observe where is the 6 o'clock position mark. If it is present on 6 o'clock position, that's good, it's fine, nothing to do. But if it is displaced from this position, then we have to change the axis of our prescription to overcome this difficulty. So the rule of thumb we use is LARS. LARS means if there is a left rotation, then you will add, and if there is a right rotation, then you will subtract. Okay. Now, if this is a contact lens, this rotation towards the left side, is known as clockwise rotation. Clockwise. So if you see rotation clockwise, if 6 o'clock position mark is present on 7 o'clock, 8 o'clock, 9 o'clock, this is clockwise rotation, or you can say rotation towards the left side. In this case, you have to add. What you have to add and how you will add, we will discuss this with an example later on. And if the rotation is like this, towards the right side, it is anti-clockwise. Anti-clockwise or towards the right, in this case we have to subtract. So this is the rule of thumb for assessing lens rotation in soft toric contact lenses. Let's do a couple of examples so that we can see how it works. Let's suppose we have a patient with prescription +3 and -4 cylinder at 90 degree. When we are assessing the fit of this soft toric contact lens, we observe that 6 o'clock position mark was present on 7 o'clock. We know that there are 12 o'clock, or you can say 12 hours in the clock, and the rotation is 3 by 60. So if I divide 3 by 60 with 12, I will get 30 degree. It means that 1 clock hour is equal to 30 degree. So in this case, the rotation was 1 o'clock. It should be present at 6 o'clock, but it was present at 7 o'clock. So 1 o'clock was the rotation, and 1 o'clock rotation is equal to 30 degree. So we have to change axis by 30 degree. And clockwise rotation, which was also towards the left side. Okay. So we have studied LARS rule. For left we have to add. Okay. So here we will add 30 in this axis. So the prescription will become +3 with -4 at 120 axis. So this is how the prescription changes when 6 o'clock position mark changes, or when the lens rotate on the eye. And one important thing, when we are saying right and left, we are saying with respect to the examiner. Examiner is viewing the patient, and then right is examiner's right and left is examiner's left. Let's see another example where there is anti-clockwise rotation. We have the same patient, same prescription. When assessing the patient, we came to know that 6 o'clock mark was present at 4 o'clock. Okay, 1 clock hour is equal to 30 degree. So there is a difference of 2 clock hours. So the change in axis will be 60 degree. And here 6 o'clock position mark is moving towards the 4 o'clock position. It has moved from 6 o'clock to 4 o'clock, which means that it is a rotation towards the right side. And according to LARS rule, for right rotation, you have to subtract. So I will subtract 60 from this value of axis. So the prescription will become plus 3 with minus 4 at 30 degree. Sometimes in exam, the question asked regarding the lens rotation does not mentions the clock hours. It simply tells you 15 degree rotation towards right or left. Okay. In such cases, again simply apply this rule. If the rotation is towards the right side, then you should subtract 15 degree from the axis given in the question. And if the rotation is towards the left side, simply add 15 in the axis given in the question. So this is LARS rule of thumb for assessing and evaluating and managing lens rotation.